So here's our kit. And what we can do, now this thing, here's the board. And let me see if I can zoom in on this for you. All right, here's the board. If you look at the board, you can see all kinds of stuff. I've got it upside down for you. Okay, here, we'll turn it right side up. Here's U1, which is this. This is the socket for U1. You notice there's a little notch right here. And then there's a notch on here. So pin 1 is down on this side. And basically what you do is you put this guy in the holes like this. And what I do is I flip it over and I just bend back a couple of the tabs. That'll just hold it in place. So it's there and it can't fall out. Okay? Okay, I'm trying to figure out what that guy's called. W1. Oh, W1. Okay. Got to make sure I've got this in the view. See that? It says W1 right there. And this is W1. So I can take this and pop it in the thing. Now, that's not correct. I need to put it in. So see, there's a flat side here. And there's a flat side indicated here. That's what we need to do. Okay, now this the leads had some little detents on it, so it's just staying right there. All right. Well, so in the process of doing this, we need to learn how to identify parts. And so here we have an integrated circuit socket. Here we have a variable resistor. And they call it, in this case, they call it an adjustable resistor, or it might be called a pot. But it says 503, which is 50K, 50,000 ohms. So, I think it might be smart if we start putting these little tiny parts in there. I hope you enjoy staring over my shoulder. So I'm going to start with the capacitors. And this is a 471. Now, a 471 is 470. Now, that's C5 or C6. So, I look on here. Now, if you can see where you got the little double lines. Those are capacitors. Right here, that's a capacitor, that's a capacitor. See all these where they've got the indications? Those are all capacitors. So what I'm looking for is C. Wait a minute. I forgot what I had here. Okay. 471. 471. C5 or C6. So, there's C7, C3, C4. C9, C9. C5. Now it's C5. And what I'm going to do is stick that in there. And I'm going to leave the leads relatively short. Because at some high frequency applications that would make a difference. It doesn't make too much difference when you're working at 7 megahertz, but there's C5. Okay, let's see what the next one is that I have. This is a 473, which is C9 or C10. Now remember C9. Here's C9 up here. And I push that through till the lead length is fairly short. And then I just bend it out, keeps it from falling out. Okay, the next one. Okay, I'm going to turn on my soldering iron and let it start getting warmed up. Because pretty soon here I'm going to solder a bunch of these, clip them off, and then put in some more parts. I used to do this all the time. This is a 473. C9 or C10. Okay, now here is C10 right here. Now this is not what you'd call a real easy kit. As I said earlier, you have to be able to identify the parts. Oh, see there, I pulled it out of your view again. It looks to me like I've got all of the standard capacitors, non-polarized capacitors installed. So what I want to do is turn this over. Now, and my soldering iron is hot. Now I'm going to use a little vise. You don't have to have one of these, but when I'm dealing with something this small, this makes it a lot easier to do. Alright, now you can see this. Now I'm going to solder. Start by, I've got a wet sponge here that I wipe my soldering iron on to clean it off. And this is my favorite shape of a soldering iron for through-hole stuff. Now you see I put a little solder on the iron itself. That'll help transfer the heat to what I'm soldering. Now when you're soldering something, I put it on both the wire and the terminal that it's supposed to go on. Now, if you do not get both parts, the wire and the pad to the temperature that the solder will work at, you'll get a cold solder joint. So and this actually appears to be a pretty nice board. The pads are run all the way through the board, so I could solder from either side, although this is the bottom side. This is the easier part to do. Now I'm going to, oops, right here are the 4 pins for the IC socket. And I want to bend that over a little more, and I want to bend this one over a little more so they stay better in place. Now I'm going to turn this. And I'm just going to go right down, solder each one of these pins. That looked like it needs just a little bit more solder. Okay, well, I've got it at this angle. I think I'll do this one. This one. Oh, now see these pins right here? These three, those are for the variable resistor. So all right, now I have these side cutters here. I like these for trimming off because you can get it right down to the board, but they're nice to have. I'd have either this or I'd have a pair like this right here. These little guys. This one doesn't quite get as close, but one of the things I do is I grab the thing I'm taking off. Oops. Okay, that's with those pliers, and I'll go, these are my favorite ones for this. They work a little bit better. Got the shakes? I'm arm rest for a moment here. Now notice I grab these. If you don't grab them, they're liable to just shoot across the room, and here I'll illustrate what I mean. Oh, it's not going to do it. Oh, these are too tame. Sometimes when you clip them off, they just go shooting. And they're a little bit dangerous because, especially if you're not wearing some kind of glasses, they'll poke you in the eyeball. That's no fun. But I've always worn glasses, so. Now, I'm going to inspect this. All right, now, let's do these little, well, we could do some diodes. Now you can either just bend these things by hand by picking them up, bending them over, or you can use a pair of pliers to bend them over. This is really a nice small pair. But I have another set of needle nose that's quite a bit bigger. These here. I've actually had these since I was a teenager, and used them for a lot of projects. But let's see. Where are the diodes? Oh, diode 1 and 2 is a 1N4001. That's these. And diode 3 is the 4148. And that's this one here. So here's diode 3. Right here, you can see it's marked D3. And notice the marking there. You got a triangle and then a crossbar. Remember I said the crossbar is on this one, because it's light colored, the end one is black. So that's the crossbar. And you can see, if you hold this right in there, that if you bend the lead straight down from the device, it'll fit into the holes. So that's what I'm going to do. In fact, I'm just going to do this by hand, show you that you don't have to have any special tools, but they're kind of handy to have. Now again, here's the stripe that goes all the way around here, the black, and there's the single bar right there. So that's the orientation you put this in. And my hand's probably right in your way. You pull this down till it just about hits the board, or in a lot of cases until it hits the board. Okay, and then go over on the back side and bend them out. This one I didn't quite get down as far as I'd want it to. Okay, there we go. Okay, now we've got two more diodes. Here's one. Here's diode 2. So, notice again, this one, the spacing is almost narrower than the width of the device itself. So I'm just going to take these and bend them straight down, like this. Line them up with the hole. Now you can see that it doesn't quite want to sit down there the same. So I'm going to bend this like this. This right here is the crystal. And I'm going to grab it right now. And that's Y1, and I'm going to stick it in here. Okay, now this version of the kit comes with several crystals, and all of the kits have these same crystals, and these little devices here have a quartz crystal in them, and it oscillates at a certain frequency. The original one is 7.023, and there's 7.050, 7.100, and several others for the frequency. So to change frequency, what you do is you change the crystal. But this kit comes with a little socket, and that's this guy right here. And what it does is it fits into this spot right here. If you look at the board, you see this circle here with two little holes, and then this guy goes into the holes. And what you do is you turn that over and you solder that in. Then after you've soldered it in, all you have to do, and I'm just going to illustrate here, all you have to do is just put a socket in there, and it'll be on one frequency. And if you don't like that frequency, you can pick out a different one and put it in also, like that. So what you'll do is you'll trim these leads back so they fit a little bit better. But anyway, that's how it's done. Bend it back so it'll stay in place. Okay. Then we got one more diode. And so I'm looking for one of those symbols like this. Oh, you can't see it. Like that. That's the symbol I'm looking for. So, let's see. Ooh. Ah, here. Diode 1 right there. And as you can see, it's that hole and that hole, and they're right up against there. And you can see the silver stripe on this one at the end toward my fingers. It goes along with this bar here. So insert this in here and then push it down. Oops, that too much on. Yeah, whoever laid this board out didn't do the best. Well, I want to try to make this go down a little more evenly. Ah! There, I made it go in. You can see it's didn't fit down perfectly, but that's one of the problems you run into. Okay. Now we've got the diodes in this end, so I think I will go ahead and solder those parts in. And I'm just going to do it right here without the holder, so you can see it's not a necessity. I'm holding the board down with a couple fingers and holding the solder in the other fingers on the left hand, and the right hand I'm using to hold the iron. Oh, okay. Kinked up fingers. All right. Trim these guys out of here. Put my finger in front of it so it doesn't go flying. Okay, inspect again. What have I got going on here? This spot right here, it looks like this one is bridged over to this one and they're touching. Not too sure they're intended to be that way. I'm going to cut them off. Yeah, I don't think they're intended to touch. That would have caused it to not work. Okay, watch out for that sort of thing. Now, let's see. Got a bunch of resistors. That's going to be fun. Now, see this little guy right here? This thing I paid $5 for. I think you can still find it for like $7. It's a little digital meter. I've bought a lot of these. I've talked a lot of people into buying it, and it works just fine. So, here's a resistor. This does not auto range, so I'm going to put this on here, and it shows nothing. So I'll go up to 2K. Oops. No. One, 10K. So if I go back down here to 20K, so that's a 10.02K. So a 10K resistor is R5. So what I need to do here is find R5. That looks like 4. R2. R5. I found it finally. R5 is right there. So, now a resistor is not polarized, so it doesn't matter which way you put it in. So, I'm going to take this and I'm just going to bend this all the way around like this. Okay. Now notice they're showing a circle here. It really doesn't matter which way you put it in except for a mechanical thing. So I would just do it the way that they're showing it. So I'm going to put this resistor in here and put it down. See how that is? And then I'm going to bend the leads over so it doesn't fall out. Okay, next one. This looked like orange, violet, orange. Orange is 3, 7, followed by, followed by 3 zeros. Maybe that's supposed to be red, not orange. Hard to tell on some of these things. So, oh. Oh. Oh, for crying out loud, look at that. Well, I can see it now. Orange, orange, orange. 33K. So that is R2. And R1, R3, R4. Oh, the search goes on. Let's see. R4 there. L, no. R, no. I need R2. Oh, right here, R2. Oh, it goes from here. Here's the circle. Here's the circle right here, and there's a little line over there indicating. So, just bend this all the way over like this. And put it in there. R2 is in. Okay, one more resistor here. This is a brown, black, red, I think. Brown, black, red. Brown is 1, 0, and then red is 100, 2 zeros, so that's a 1K. That's R3. Aha! R3 is right here. So, bend that over, stick that in there. Oops. Okay, R3. Let's see what else we've got here. Oops. I didn't pin that one down and it jumped down onto my shirt and onto the floor. Okay. Oops, I missed a... Aha! Well, it's starting to come together. We're going to encourage everybody that would like to do CW, build a little transmitter, that you purchase one of these. And it puts out less than a watt, maybe 100 milliwatts, a tenth of a watt, but it'll transmit across the room, and in some cases around the world. People have literally made contacts for thousands of miles, which is with very little power. And we're hoping that a few of you will build these, and then we'll talk to each other and we'll learn a little bit of code. I'll teach you how to do your call sign. Mine is da-da-da, da-da, da-da, da-da-dit, da-da, da-da-dit, da-da-da-dit, WA7MHB. So, now, I'm going to take a rest, and I'll be back in a little while, and I'll finish this up for you guys. Okay, I'm back. I'm going to turn off this heater, get rid of all the extra noise. I want you to notice I have my cup of tea. Now, I don't think because of the size of my cup, which is very large, here, my Christmas cup, It's the only thing that keeps me going. I've had my nap, and well, I think I'm going to get a little more light here. There we go. Now, while I was gone, I came up with this. LM386. I have 9 of them. There were 10 in the package originally. So, fortunately, I've got that and I don't have to worry about it. Well, I got all these extra capacitors. Boy. Okay. I think we'll get started here so you have an idea of what's going on. When you're building a project like this, some of the old kits, Heath kit for instance, they had everything in the manual, and they went through it step by step. They showed you where it was. They made things really easy for you, but you ended up with a thick book that explained how everything happened. And you can still find kits like that, but it's more fun, at least it's more fun for me to learn where things go. So I'm gonna put these inductors in there, and see, I'm gonna need my eyes. Okay, this is brown, black, gold. So using our measuring device, or our stuff here, brown is 1, black is 0, and gold, it is 0.1. So that's 1 microhenry. That's L2 here. Let's see if this is getting on the screen. Yeah, L2, as you can see right here. So we'll find L2 in our list. Get this oriented correctly. There's L1, L2 right there. So I'll bend this guy over. Hopefully you can see what I'm doing here. Okay. All right. Okay, there's L2. Now we have orange, orange, black, 33, 22. No, that's, well, I guess that's red, 2 reds. 22 microhenry. And this goes, now this is a coil. They call it a fixed inductance. There's L3. L1 is what we want. So that's, oops, wait a minute. L1 right here. An inductor is a coil of wire. It can be just a thing that goes like this, or it can be wrapped on itself. Anyway, it creates inductance. And we'll let DC go through, but high frequencies it will cut off. Okay, now this last inductor right here. Oh no, oh looky here what I found. I found my LM386. It was sitting upside down, so they had the part. I didn't need to find one on my own. Well, very good. Okay, This is brown, black, brown, 100. So it's L3, 100 microfarad, or microhenry, excuse me. It's a little more coil than our 1 microhenry, or our 10 microhenry, but where was that? L3. L3 goes right here. We see a circle that indicates the vertical part of the inductor, and then the spot where the wire goes, and we bend that over. Then we have 2 transistors. Q1, or well, let's see what this is. This is, try to get some more light on it so I can see. $80, $50. 80, 50. Okay, this is Q2. Q2's right here in the middle. And notice the shape drawn on the board here. At least you don't have to figure out which is the emitter, base, or collector. We'll spread these wires out just a little bit. Okay, and you can see that the flat side is here. So I'm going to put the flat side of the transistor there. Push this through, and this one I'm going to leave a little longer lead length, because if they get warm at all, that will help keep them cool. So there's that one, and then of course the next one is the 9018, which is an S9018. All right, and here is Q1. See here we got 9018 Q1, and it goes in right here. Noticing again the orientation to make sure it goes in correctly. Okay. Yeah, I think I'll go ahead and solder these. Get just a little bit of soldering on my soldering tip to help transfer the heat. And then hold it against both the PC board and the wire that I'm soldering. So I get both parts hot. Now on transistors, and actually diodes, you don't want to leave this on too long, because you can damage the device by overheating it. They're pretty sensitive to that, although it's been extremely rare for me to have damaged anything that way. Let's see here. Oh, there it is. All right, I got these parts. I think I need to trim that guy just a little bit more. Okay. Now I'm again looking for any cold solder joints or anything that doesn't look like it's soldered correctly. Okay, looking pretty good. Now, we need electrolytic capacitors. Should be 4 of them. One big one. This is 100 microfarad at 25 volts. With an electrolytic capacitor, you can go higher in voltage. You could have 100 volts or 1,000 volts. What's important is that the the capacitance is the same. Problem is, with a high voltage one, it'd be much larger. So here's the electrolytic capacitor here, CP1, and the positive. Now notice there's a little plus right here. In fact, I'll use this to point. See, right there's a little plus, and then they're indicating the negative side right there. And if you look at the capacitor, you can see this minus on this one side with an arrow. They just, these things that they shrink on here have this mark. So that indicates the negative side. So the negative side goes to the negative side, and in this case the longer wire, which is the positive, goes there. So, alrighty, now the other 3 are all 10 microfarad. C2, C3, or CP2, 3, and 4. I need to find them. Oh, here we go. Okay. Notice again the gray stripe with the minus is on that side, so you put that with the opposite from the positive, which goes here. And okay, and let's see, here's, oops, try to put it in backwards. Don't want to do that. The thing with electrolytic capacitors, you put them in backwards, and these little guys will go pop, bigger ones explode. Oh, I remember when I was in the military, I happened to be out having my gedunk break, and I heard a big bang. I went in, an electrolytic capacitor had let go in one of the pieces of equipment, and that was an old tube type piece. That was a long time ago, I know. Anyway, we opened up the back of this equipment, and it was full of aluminum foil. Quite an exciting experience. All right, transferred a little bit of solder on there. Okay. All right. Find my cutters. After you get the hang of this, it becomes pretty easy. And it's a lot of fun. At least I find it to be fun. I'm really enjoying this. I'll get that in a minute. Oh, where did it go? Ah, there it is. Okay. Now, for a little bit of tea. Okay, now. Now we get to put in these other devices. Okay, now here's the... Oh, wait a minute. Uh-oh. Okay. I think I just ran into our first problem. DC 9 to 6 volts. This is the input. Oh, I see. Oh, boy. Look beyond the end of my nose. I was looking at these 3 holes here. I didn't even notice these over here. So, this goes in there, like so. Some people would find some way to set this down and leave it, but I will do like that. Okay, that's in. Oh, I might have to, I still might have to clamp that before I solder it. Okay. We've got the BNC connector. Now this is called a BNC connector here, and this is your antenna hookup. Most of you will be familiar with what is called a UHF connector. I've got this real quick disconnect, but this is what you're familiar with. And that's real common, but the problem with these guys is they're not very good at extremely high frequency, where this is good to extremely high frequencies. And but that's, of course, that's not critical here, but it's a real common connector. In fact, this is a male, here's a female. You just shove them together like this and twist it, and then it's on there solid. And that makes a really good connection. Oops. I see I got out of the picture. There we go. Anyway, look at this. This is a BNC connector. And here's what mates it, and this would be like to the antenna, except this is going to one of my pieces of equipment here. So Well, what's going on here? Oh, there. Okay. That might have been out of your viewing here. I'm going to back up. I'm going to take this apart. I had a hard time getting this together. And I want to show you why. If you see these two little terminals here, there's two little holes. Well, first I was trying to stick it in these holes, and that's not where they belong. They belong over here. And then these pins end up over here. And of course these big pins are the ones that hold it in, and this is what handles the RF. But anyway, when you got something like that, it's best to get the two little wires going first, because they will bend around a little bit, which is what was necessary, and then line up the holes for the other part. And I'm going to bend those over, which will help keep that in there. Now, I think that I need a clamp. And I have a clamp. This is actually my ground strap. Okay, now you can see what's going on. And notice I've moved around with the soldering iron so I could heat both the terminal that I'm soldering and also the PC board pad. This is a significantly bigger connector. Okay, now those two will hold it in, and I can then solder this last piece. Okay, now we've got yeah, I did it again. I pulled it over where you can't see what's going on. Someday I'll figure out how to do this in a professional way, but for right now, this is it. It's going to take a little longer now to get this hot enough, because this is a lot bigger piece. Need to transfer the heat. It's getting there. There we go. See, now it started taking the solder. Okay. Now we got two more pieces. Actually, just for fun, I'm going to take these little screw things and screw them on here. They aren't even actually needed, but you know, maybe I'll stick this in something someday, and then I'll put a couple holes, take this off, stick these through the holes, and screw it down. Now there's two of these. Up, stand by. Okay, that was my wife calling me from in the house to tell me dinner's almost ready. So you can see the pattern here and the pattern here, and all you got to do is line these guys up, stick them on, and I'm going to use my little clamp to hold it in place. And then solder a couple of these. So I got it both on the terminal sticking through and the pad. Okay. I suppose I got out of your view again, but I'm not going to do this twice. There we go. Now, one thing you might not have been able to notice is I have the soldering iron on one side and the solder on the other, so that when the solder started melting, I knew the part was hot. And so ensure that I get a good hot solder joint. Now, we got one more to go here. And Janet just called me and told me dinner's ready. Oh, look here, I missed this. Right there. I'll need to be sure that I go back and get that. I'm getting a horse talking too much here. Got that one over there on that side that I had missed. Okay, now I can disconnect this guy. I had a little trouble getting that hot enough. All right. Now, I'm looking at all the terminals. This guy here, I guess you can't see much. Little eyepiece, very handy if your eyes are as old as mine are. Anyway, there we go. It's complete. The only thing we need to do is to put this in. And you can see right here, right there, a little notch, a little round notch right there. Notice the little round notch right here. You line those up. So what you do, these line up nicely. Sometimes you got to put in one side a little bit and then the other. Okay, all right, now it's going to make a liar out of me. Okay, come on. Okay. I'm doing something I should not be doing. Oh, for crying out loud. All right. Yeah. There we go. I got both sides started. There it is. Complete. I'll be back to you in a little while and I'll check things out. Anyway, God bless you all, and this is a fun project. We'll do a little bit to see if it works in a little while. Meanwhile, I'm going to have some dinner. Thank you. Somewhere. Okay, I have set up our new transceiver. I'm going to check its ability to transmit. I've actually already checked, but just so that you see, I've provided a 50 ohm load right here with this. This is an earth ground. This is my power cable, which I've got hooked up here to my power. That's 12 volts, or actually 13.8. And then this is the key here. And I can transmit. Now you might be able to hear this in the background. Made a mistake. WA7MHB. I don't know if you could hear that in the background. Actually, I'll go turn it up. A little higher pitched. Maybe you can hear this now. Can't even send my own call sign. There. Now, you can hear it on my receiver, hopefully. And I have it showing up here on my oscilloscope. And I'm going to show you that here in just a moment. Okay, you've seen how I've got it set up, and now this is my oscilloscope, and I'm just going to pan over here a little bit so I can explain what these connections are. Here, let's first take a look at it, and you can hear it. And see it. Now, I have the oscilloscope right here switched over to channel 2. This is channel 2. I have it on 5 volts per division. And then over here I've got 0.1 microsecond per division. So that's just one back from its maximum, which is 0.05. Oops, I'm turning on the wrong thing. Oops. Oops. Here. Right here. That's 0.05 microseconds, 0.01. And here, if we tune it up, if we go there, you can see that's the maximum. Just slowing it down a little bit, even a little bit more. So, That's a 7.023 megahertz signal. So I want to show you that again. That's 0.1 microseconds, 0.05, 0.1, and 0.2 microseconds per division. I happen to like it there best. And we have at 2 volts per division, when we key it up, we got 5 volts per division. From 0, here's 0, up 5 volts, 6, 7, 8.5. So if we take 8.5 and we multiply that 8.5 times 0.707 equals 6.0095 volts. So that is the RMS value of the peak. So we take that and we square it and we get 36.11, and then we divide that by 50 ohms, which is the resistance, and we get 0.722 watts. So this is a QRP rig. Now later I will try hooking it up with a pair of headphones and see how it receives. Thank you. Okay, I've got a pair of headphones hooked up to it, and when I put them on I can hear a little noise, so that's good. And now I'm going to hook up an antenna right here. Still nothing but noise. Okay, I'm going to try hooking my signal generator to it. But I'm going to disconnect the key just to make sure I don't accidentally transmit into my signal generator. Even at less than a watt, it could damage it. So, let's see what I've got here. Well, my signal generator, you can probably hear this. From here. Let me tune it around just a little bit. I am at the moment putting out 0.015, that's 150 microvolts. And I can still hear the signal in the, it's not much of a receiver. Take a loud signal to get through to it. But it's working. We have successfully built a little radio, and it's a transceiver. So we can use it to talk to each other, at least across the room and maybe across the town, And we shall see. It'll depend on the antennas we use with it. Thank you.